In this video, I'm going to talk about the rational roots theorem. Now, the rational roots theorem is a very useful theorem when we're solving polynomial equations. A polynomial equation might look something like this. 0 is equal to x cubed plus 10x squared plus 29x plus 20. What I would call the roots are the values of x that satisfy this equation and make it actually equal to 0. Now, we could have all kinds of different numbers for those, but this theorem tells me that all of the rational ones, that is, all the ones that can be written as fractions, must be of a certain form. Okay? That is, the theorem is all possible rational roots of a polynomial can be found by looking at plus or minus p divided by q, where p is equal to factors of the constant term, and q is equal to factors of the leading coefficient. Okay? Let's put that into use here. I have this polynomial up here, and so my p term, I look there, and that is going to be the factors of the constant. So look here, so factors of 20, as you really should say p equals, because p could be the factor, so factors of 20, and factors of 20 could be, say, 1, we could have 2, 4, 5, 10, and 20. Those are all the numbers that we can evenly divide 20 by. Look at the first term. The first term is just a 1, the coefficient of the x cubed. So factors of 1 are just 1. Okay? Now what that tells me is that the possible roots I can narrow down. Okay? And possible roots would be plus or minus 1 divided by 1, which would be a plus or minus 1. We have plus or minus 2 divided by 1, plus or minus 4 divided by 1, and so on. Okay. Now that's still a lot of different things. It's really important to note that these are not all roots of this polynomial. They're just the ones that possibly could be. Now it still seems like a lot because I have 2 possible here, so 2, 4, 6, 8, 10, 12. I still have 12 different things that could work here, but I've narrowed it down from any number I could imagine to just these 12. Now once I have these 12, I need to actually find out which one it works. And I could try a bunch of advanced things, but the easiest here is probably just start plugging some of these in here and see if they work out. So I'm going to set up a table so that x value, and then I'll have my f of x. So that'll be like, if I call this function here f of x, what would I get if I plugged in these values of x? And then I'm going to ask whether that was a root. So I'll start with, I'll plug in positive 1. Let's see if that's a root. If I plug in positive 1, I would have 1 cubed, which is 1, plus 1 squared is 1, times 10 is 10. Plug in 1 for x there, I get a plus 29. And I plug in 1, well, I don't have to plug in 1 there, I just get plus 20. Right? I could add that up, but it's most certainly not going to be equal to 0. So you'd have 20 plus 29 is 49, 59, I get 60. Which tells us, nope, it cannot be a root. If it were a root, it would make that equal 0. So in my list, 1 was a possible root, but it didn't turn out to actually be a root. Try negative 1 next. If I plug in negative 1, see negative 1 cubed would be a negative 1. If I plug in negative 1 right here, negative 1 squared is positive 1, times 10 is plus 10. If I plug in a negative 1 there, 29 times negative 1 is 29. So I can be subtracting 29. And then I just add 20 at the end. Now I got some numbers to crunch here. Negative 1 plus 10 is 9. 9 minus 29 is negative 20. And negative 20 plus 20 is 0. Okay, so that tells me when I plug -1 in here, I actually do get 0 out. So it tells me that, yes, -1 does turn out to be a root. Okay? Now I could keep going through this to find all the possible rational roots. I'll check out maybe one more. Okay. Now I'm going to reason here that by looking at this, if I plug in a positive number, this will be positive, this will be positive, this will be positive, and this will be positive. If I add up a bunch of positive numbers, I'm definitely not going to get to 0, because I can almost cross out every positive possibility here. I'll try one more, just for example. I'll see if -2 is a root. So I plug -2 in everywhere. -2 cubed is going to be -8. -2 squared, no, -2 times -2 is positive 4. 4 times 10 is 40. -2 times 29 would give me a -58. And then I add 20. So getting a little bigger here. Probably want to use a calculator. I'll try to do this in my head. Let's see, -8 plus 40 gives me a positive 32. I'm going to do 32 plus 20 to give me 52. Because then 52 minus 58 is easier to do. It gives me a -6. So it wasn't too bad there, but since it's not 0, it tells me no. Okay? So to sum up the rational roots theorem, it's a very useful tool if we're looking to find the solutions of a polynomial equation. What it does is it tells us if you look at the factors of the constant term, the plain number, and you look at the factors of the leading coefficient, in this case, what was just a 1, you can find all the possible rational roots by dividing those factors. So we're able to look at this equation without actually solving anything about it, determine that all of the rational roots would be one of these guys. And then to actually find out which ones are roots, you can just plug them in for x, do the arithmetic. If it comes up to 0, it's a root. If it does not come up to 0, it's not a root.